Hi, I'm Elton Hunter, Chief Operating Officer for SPI, and this is the ESTMP 2024 discussion for this morning. Understanding the importance of protective maintenance. This morning I'm going to talk about avoiding unwanted outages with the IPPs and utilities, the cost-effective approaches for better results, and ensuring safety and reducing exposure for the customers and their employees. Understanding maintenance challenges and issues today. Common maintenance challenges in the utilities are unplanned outages and their impact on their customers, environmental factors like storms, forest fires, acid rain, ice storms, just cold weather. Industrial contamination challenges. Each one of them, each industry has its own challenges. Proactive diagnosis with new technologies such as corona cameras, ultrasonic cameras, UV cameras, IR cameras, and even full spectrum cameras help us identify and diagnose problems. This is a 250,000 volt SF6 breaker. It's contaminated with carbon black. This is an environmental contamination from this work site, and it's completely coated the upside and the underside, the petticoats of this insulator, and is near failure. Contamination on high voltage electrical insulators can attach to the underside, under the petticoats, and to the top surface, influenced by the various environmental conditions. Wind direction and speed can carry and deposit the contaminants on different parts of the insulator depending on its direction and speed. Humidity, moisture in the air can cause contaminants to form a conductive layer on the insulator surface, significantly reducing its insulating effectiveness. The rain can wash away contaminants, but also spreads the contaminants evenly across the insulator surface, potentially worsening the situation. If the rain is polluted, or if it's frozen, then tracks over the insulator, causing a failure. Temperature extreme can affect the behavior of contaminants, causing them to evaporate and condense or freeze on the insulator surface. Pollution, the proximity to industrial, agricultural, or even coastal areas can determine the type and the amount of contamination. Electrostatic forces. The electrostatic field around insulators can affect the particulate contaminants, affecting where they accumulate on the insulator surface. These factors interact to determine how contamination adhere to and affects the high voltage insulators, impacting their performance and necessitating regular maintenance and monitoring. In this photo, you see the previous SF6 breaker. On the right-hand side, you can see at the top of the skirts are completely coated with this carbon black. It's blown in by the wind from the west. And on the left picture, you can see it's even gone to the petticoats and stick to the underside of the petticoats, which is normally a clean section, breaking that contamination layer. Early detection is the key. On the left-hand side here, we use ultraviolet imaging, which is a very special camera that helps us identify problems. Ultrasonic imaging tells us exactly where to look and identifies pinpoint places on our plant that we can take and start doing research on. The IR camera, the infrared camera, tells us exactly where there's hot spots or cold spots, also indicating different loading. Visual spectrum imaging, high resolution, helps us to identify something that we might not normally see by zooming it in. All four of these cameras help us to identify a problem before it happens or after it happens to identify what went wrong. Each camera has its own strength and its own weakness. Together, they're combined, they make it possible for us to identify an issue before it happens or after it's happened to identify what went wrong. Ultraviolet detection. Over-tightening the bushings and the mechanical stress from over-tightening has compromised this connection. Thermal cycling, the expansion and contraction of the different materials, the stainless steel, the brass, the copper, and the aluminum, in that thermal cycling, it caused this to be a failure. There was about 20% capacity on this bushing the day I was there. There was 1,000 megawatt on this system, and there was only about 20% load on this bushing. With the UV camera, you could actually see where the fail point was, and it was easy to identify. The UV imaging revealed significant corona discharge, indicating an insulation failure, and that risk was something we had to address. Pinpointing the source of the partial discharge, corona You can adjust the gain up or down on the camera. You can actually see exactly where it's coming from. By enhanced diagnostics, fine-tuning the sensitivity for accurate detection, you can actually see where the corona was coming out. Targeted inspection and identifying the exact point of electrical discharge on this bushing made it possible for us to identify what the problem was. Ultrasonic detection. On the left-hand side here, you can see this is the same bushing, and it's got a little spot, a color spot on there, and it tells us exactly where the contamination or the issue is. On the right-hand side, you can see a frequency spectrum picture, and it tells us whether it's leaking across the surface or if it's capacitive discharge. The PRPD on the bottom tells us exactly what is happening inside this discharge. Infrared, IR is great because it tells us when a part is heating up. Usually it's after the fact, and if you don't have full load on it, at the moment you take the photo, you can't really diagnose it. The thermal hotspot in this camera reveals overheating on the bushing itself. Causes, potential unbalanced load, contamination, or the bushing degradation itself. High chance of imminent component failure. Usually when we get an IR hotspot like this, the damage is already done. The action required would be immediate, repair and or replace this particular bushing. Mitigation. These photos are actually live front switching cubicles. On the right-hand side here, you can actually see one of the workers out there, and he's using high pressure air and CO2 to clean this live front switching cubicle. The stress cones that are in here were contaminated over time with dust and dirt and contaminants from the atmosphere, and he's blasted them clean, and you can actually visually see the difference between the old contaminated bushings and the brand new cleaned up ones. Innovation in maintenance using dry ice blasting. Revolutionary cleaning procedures by using rice-sized 3mm dry ice and high-pressure air. It's non-abrasive, it's non-flammable, it's non-conductive. It's faster and greener than any other traditional cleaning process. What is dry ice blasting? It cleans in 3 ways. Kinetic energy. We accelerate the 3mm pellet, which is basically the size of rice, to above 343 meters per second, or 1,100 feet per second. It's above the speed of sound. It thermally shocks the material that separates the two materials, the contaminant from the host, by rapid expansion, and it cools the contaminant on top. Sublimation. Dry ice expands 800 times on impact with the surface. It goes from a solid to a gas, and it expands 800 times. It's safe for the surface. Anything that's harder than your fingernail, it does not damage. It doesn't damage paint, soft surfaces, or harder surfaces. Insulating. CO2 acts as an insulator during its cleaning process. Its dielectric strength is 72,000 volts per inch, where the atmosphere is 75,000 volts per inch. The advantages of dry ice blasting: it removes contaminants, it reaches inaccessible spots that you could not possibly get to. It reduces downtime, no post-cleanup. You don't have to clean up anything afterwards. It's eco-friendly, it's non-toxic. There's no chemicals used. It maintains equipment integrity and prevents surface damage. The high cost of reactive maintenance. Regulatory fines from bodies like the Public Utility Board and the AUC are becoming more prevalent. Customer contractual penalties due to the outages. On January 13th, 2024, Genesee went down and had an overheated bearing. 2 other generating facilities were off at the time during that cold snap, causing all cell phones in the province to come on as an emergency alert, asking them to shut off load. It was a peaking, a little over 11,000 megawatts was on, and 200 megawatts was dumped within 2 minutes, helping to keep the system on and avoiding a brownout. The dollar value impacts on O&M budgets is something that all utilities are concerned with. Safety-related costs and injuries. Anytime a staff member is injured, it affects all of us. Reliability metrics and their financial impacts is very hard to determine. Using an ROI calculator, return on investment calculator, makes it easier for us to understand the true cost of an outage. Maintenance technologies, a comparative study. The pros and cons of different cleaning methods. In this particular case, you see someone out there and they're using compressed air and ground up corn cobs, corn blasting. Afterwards, they wipe it down with chemicals, which are solvents, and they're very destructive to the environment. Or they're using deionized water on energized equipment. Wet versus dry cleaning methods. Each one of them has their strengths and weaknesses. Corn blasting. It's not as green as it actually seems. What we do is we take ground up corn cobs and we blast them under high pressure, just much like sandblasting, and it ends up being in the environment. It's very harmful. It's biodegradable on its label, but what it does is introduce a whole bunch of material into the ecosystem inside the switching cubicles, transformers, and the high voltage equipment that we're working with. Electrical hazards, well, the risk of damaging sensitive equipment and parts with abrasive corn cobs and their particles. Removing the deeply embedded contaminants afterwards is almost impossible. And limiting the effects in the cleanliness around tight spaces and enclosed electrical areas is another problem that corn blasting has not addressed. The impacts and implication of corn blasting. Drawbacks to this method, notoriously, we have to struggle with the grime and grit into the ecosystem. Dust creates respiratory hazards for the workers, and static can cause or ignite fires. Environmental setbacks. It necessitates extra cleaning and adding to the downtime, or the use of corn cobs raises disposal concerns. Abrasiveness may harm equipment and the surfaces on them. Corn remnants invite insects, leading to the chain of pest infestation, property damage, and reclamation of the site. Pressure washing. High pressure water can harm insulators. Water ingress risks the freeze-thaw cycle, where water gets into cracks and once frozen expands and contracts and then dries out. Environmental and safety issues. It generates wastewater and potential pollution onto the ground surface and into the water cycle. High injury risk to workers from high pressure water and electrical hazard or flashover is a problem. Limitations and hazards of high pressure water. Operational limits, not suitable for sensitive materials or cold temperatures. This causes operational delays due to the drying and cleaning up of the plant. Post-washing UV inspection shows potential for a flashover. Just prior to this flashover, you can see it on the right-hand side. Slippery conditions heighten workers' workplace safety concerns. Environmental and safety concerns. Solvents that are used for cleanup are extremely hazardous. Toxicity risks to workers and the ecosystem are explained on the container. Pollution in water and air, water resources are very difficult to contain. The high risk of fire and explosion near power equipment is something that nobody wants to deal with. Exposure leading to respiratory issues and skin damage. This material on your skin will absorb right through your skin. The operational challenge here is the complex disposal and treatment of the hazardous waste. This material is actually supposed to be used in a closed system. It's very difficult in substations with high voltage electrical equipment. The downtime for safety protocols and cleanups adds extensively to our cleaning procedures if you're using solvents. This is an example where solvents were transferred from a large barrel to small 5-gallon containers properly stored inside the truck. The volatility and the high ignition risk from the solvent is something that everybody has to be concerned with. The contamination difficulties, specializing with fire suppression needs, this material, once it catches fires, cannot be extinguished with an A, B, or C type fire extinguisher. It has to be a CO2 fire extinguisher. A catastrophic potential rapid spread of fire and severe long-term outages and economic losses are something that solvents will have to be addressed. Personal danger. The imminent risk of burns and inhalation injuries and long-term health effects from chronic exposure, either inhaling it or just absorbing through your skin, and they change your DNA. If you plan to have a family afterwards, you should talk about this with your doctor and determine the right course for you as a worker. We did a case study on a small utility here in Alberta. It highlighted the impact and benefits that were realized by using dry ice rather than solvents and corn blasting. Key challenges. Recent incidents, 2 major failures in the high voltage switching cubicles of approximately 137 units ended up catching on fire and causing an outage. The customer outages, it has a high cost of repair. Emergency crews had to go out on a call out after hours. Hidden risks. The discovery of self-extinguishing fires in cubicles indicated potential for future issues. Replacement time of 18 months. This is something that all utilities have to deal with, in that it takes them approximately 18 months to get new switching cubicles, as they're hard to get right now. You can see that the switching cubicles for the 2 that caught fire was approximately $180,000. The labor cost on overtime was approximately $40,000. $220,000 for 2 switching cubicles to burn up. The indirect costs, well, there was regulatory fines of $2.1 million. The lost revenue was not selling electricity to the customers was never recouped. The total investment cost is hard to calculate, but it's something that we'd like to take and point to as something that people sometimes don't think of. The actual impact is the loss of trust from our customers to us, the utility suppliers, and the reliability and safety concerns that they have now with a system that's not properly maintained. An eco-solution, dry ice blasting used to complete the cleaning on energized switching cubicles. The advantage of environmentally friendly, it's non-conductive, there's no secondary waste to clean up. Comparison with traditional methods, more effective, it's less abrasive than corn blasting and reduces equipment wear. Savings and longevity, cost efficiency. Implementation of dry ice blasting across underground switching cubicles achieved a 15% reduction in the cleaning and maintenance costs. No interruptions. Completing this work while energized eliminated customer outages and enhanced equipment longevity, reducing wear and tear, leading to longer equipment lifespan. Prevention and risk mitigation. Proactive approach, regular inspections and cleaning cycles, which was introduced. Risk mitigation significantly decreases the emergency repairs and unplanned power outages. Long-term benefits, it ensured continuous power supply and improved customer satisfaction. Success stories in maintenance. A summary of achievements. The utility successfully addressed the power outage issues through an innovative cleaning solution. Its effectiveness, marked improvement in the equipment performance and reliability. Future outlook. Plans for continued innovation include annual inspection and exploring future technological advancements. Steps towards improved maintenance. Cost considerations for the equipment and purchase for this type of procedure. Field service options and training. An ROI calculation and justification. Embracing the future for maintenance. Recap of these new technologies and procedures. Dry ice blasting is something that makes it safer, better, quicker, faster, and cheaper for all utilities. Key consideration for the utilities is reduction of unplanned outages, and a call to action for adopting proactive maintenance strategies is what all utilities and IPPs should be looking for in the future.